Welcome back. In our previous video, we looked at the 2x2 case and strategies for solving a system of linear equations using Gaussian elimination in matrix form. Now we're going to take a look at the 3x3 case. So here we have the system, and in general, let's go ahead and write a 3x3 system as a11 times x plus a12 y plus a13z equals some constant, which I'll just call constant for row 1. And then we'll use the second row, so a21x plus a22y plus a23z equals some other constant, and a31x plus a32y plus a33z equals constant 3. Now just note that the first subscript denotes what row we're in, and the second subscript denotes what column we're in. So A11 just means that we're in row 1, column 1. A12 means we're still in row 1, but we're now in column 2. A13 means we're in column 3, and then you can see here that the first subscript always just notes what row we're in. So if we wrote this in matrix form, we might write A11, A12, A13, and C1, A21, A22, A23, C2, and A31, A32, A33, and C3. And then, of course, we could put our bar down the off one column from the right to just denote that that's where our equal sign is. So it's really, really important that, again, our x, our y, our z coefficients are in respective columns, and then here we have, again, our constants. Now what we want to do here is we want to get this into a final form that looks like this. 1, 0, 0, some number, I'll just denote that again with a question mark, 0, 1, 0, some other number, 0, 0, 1, and some other number. And the reason we want that is because when we read this off, we can see that this still is equivalent to the first system, where x is equal to the first question mark, whatever that value might be. 0x plus 1y plus 0z is equal to the double question mark, and z, or 0x plus 0y plus 1z, is equal to the triple question mark. And in order to execute this strategy, we're going to use kind of the 2x2 system strategy, where the first step is going to be to, well, it could go a number of different ways, but it might be easier in this context to get the first coefficient here to be a 1, use that to eliminate and create zeros here and here. Then we're going to move inwards. And so now we're going to use our second equation as the pivot. We're going to make that into a 1, and then use it in whatever order we want to make this a 0 and make this a 0. Then we move in even one column further, and we now focus on making this a 1 and using it to create zeros in both places above it. It doesn't have to be the case that you work from, that you have to use the 1 to cancel out the 0 here first, and then here. You could use the 1 to cancel out and create the 0 here, and then the 0 here. But we need to make 1s in our first column, create a 1 pivot in our first column, use that to create zeros below it, create a 1 in the second column, second row, use that to create zeros above and below it, and then create a 1 in the third row, third column, and use it to create zeros in both rows above it. And this is the strategy of Gaussian elimination. This is how computers process this in order to make it happen. So for this system here, let's go ahead and first convert that into a matrix form. So I have to be really cautious here because my variables are not arranged in the correct order. So if I want x, y, z, and then my constant, what I'm going to have to do is observe what the x coefficient is in the first equation, which is -2. There is no y, so that means I have 0 y's. So negative 2x plus 0 y plus 1z equals 1. In the second row, I have 1x plus 1y plus 1z equals 10, and 2x minus 1y plus 2z equals 11. And this is the system that I have to work with now. If there are any zeros in there, that might be a handy tool where you might be able to skip a step later on down the road. So to perform Gaussian elimination on this, first of all, I see that the second row is already a 1. So I certainly could take negative 1/2 of row 1. I'm going to create some fractions there. So what I'm going to go ahead and do is I am going to take and switch row 1 and row 2. So all I'm doing here is just changing the order of the equations. Again, if these are 3 planes in 3 dimensions, they're still going to intersect at the same point, regardless of what order I consider them in. So I'm going to switch row 1 and row 2. That's going to give me 1, 1, 1, 10, negative 2, 0, 1, 1, and row 3 is untouched. Whoops. It's going to be an 11 there. Okay. So now my strategy is, okay, I wanted to make that first row, first column value a 1, which it already is, so I get to skip a step. Now I'm going to use that 1 to help me cancel out the negative 2 in the second row and the positive 2 in the third row. So I'm going to take 2 times row 1, add it to row 2, and store that result in row 2. So row 1 doesn't get changed. Row 1 is going to stay the same. And row 3 is going to stay the same because I'm not doing anything to it quite yet. And so 2, negative 1, 2, 11. It is also totally valid to swap row 2 and row 3 if you see that that's going to be beneficial for some reason. Oftentimes we just do row swaps whenever it's going to help us or it's going to be convenient to create that 1, 0, 0 structure. So if I take negative 2 times row 1 and add it to row 2, I'm going to have 2 times 1 added to negative 2 is 0. 2 times 1 added to 0 is 2. 2 times 1 added to 1 is 3. 2 times 10 added to 1 is 21. So far I've achieved the 1, 0 in the first column. I'm going to again use the first row to pivot off of to cancel out the 2 in the third row. So I'm going to take negative 2 times row 1, add it to row 3, and record that result in row 3. All right, so that means I'm keeping rows 1 and 2 the same. And if I take negative 2 times row 1 and add it to row 3, that's going to give me negative 2 times 1 plus 2 is 0, as I wanted. Negative 2 times 1 is negative 2, minus 1 is negative 3. Negative 2 times 1 plus 2 is 0. And negative 2 times 10 is negative 20, added to 11 is negative 9. Now I see something interesting here, and in our final steps, remember we're going to want this value here, to be a 1. Because the third row is always going to tell us what the value of z is. Now, it doesn't have to be the case, but this is the way the algorithm works. So to keep consistent with the algorithm, I want this to be a 1. And there's nothing I could scale 0 by to make it a 1. So instead, what I'm going to do at this point is I'm going to go ahead and interchange row 2 and row 3. That gets me, all that's going to do is it's going to give me a non-zero constant in this bottom row. And it's not going to change my 1, 0, 0 structure in the first column because, well, the second and third rows already have zeros within that column. So I'll have 1, 1, 1, 10. Then I'll have the second row, which will be the row swap between row 2 and row 3. And 0, 2, 3, 21. This should be a negative 9. All right, so it looks like we've done an okay job there. So now the the optimal step is to make, we want this guy here, we want this guy here to become a 1. So to make that a 1, that's going to require scaling the second row by the appropriate constant. Well, if this reads negative 3y equals negative 9, then if I multiply or divide the whole row by negative 3 on both sides, then I'm going to get a 1 here. And not only that, it's also going to reveal the value of y at this point. So we're going to take negative 1/3 of row 2 and store the result in row 2. So rows 1 and 3 stay the same. And now, if I take negative 1/3 of row 2, then that's going to give me 0, 1, 0, and positive 3. I don't know why I wrote that in pink. 0, 1, 0, 3. Awesome. So now what I want to do is I'm still focusing on this second row, second column value. I want that to be a 1, but now that I have it as a 1, I'm going to use it to cancel out the 2 and to cancel out the 1 as well. So I'm going to take, if I take negative 1 times row 2 and add it to row 1, that's going to cancel out the 1 up top. Again, it doesn't matter whether you cancel out the 2 below or the 1 above. And I'm going to store that result in row 1. All right, so that means second row and third row are staying the same. I'm only changing the first row. And the way in which I'm going to do that is by taking negative 1 times row 2 and adding it to row 1. That's going to give me, let's see, negative 1 times 0 plus 1 is 1. Negative 1 times 1 plus 1 is 0. Negative 1 times 0 plus 1 is 1. Negative 1 times 3 plus 10 is 7. Now I'm going to take this 1 and I'm going to use it to help me cancel out this 2. So I'm going to take negative 2 times row 2, I'm going to add it to row 3, I'm going to report the result in row 3. Negative 2 times row 2. Okay, so negative 2 times row 2 added to row 3. We're going to leave rows 1 and 2 the same. And now row 3 is going to change. Negative 2 times 0 plus 0 is 0. Negative 2 times 1 plus 2 is 0 as desired. Negative 2 times 0 plus 3 is 3. Negative 2 times 3 plus 21 is going to be 15. Almost there. So now we have 1, 0, 0 in the first column. We have 0, 1, 0 in the second column. Now we're moving into the third column. So don't worry about the columns that you've already gotten into the correct structure. Those won't change. Those values won't change anymore because we're going to be taking multiples of 0 and adding it to other things. So now we just have to focus on the third column, and we want this 3 to become a 1. And then we're going to use that 3 to cancel out this 1 here. Why are we doing that? Well, if you think about what the first row says, it says x plus z equals 7. That's not very helpful because we want the first row to tell us what x is. The third row is going to tell us what the value of z is, and you can probably see already that 3z equals 15 is the same thing as saying z equals 5. So when we're saying we want to make this into a 1, what we're really doing is taking that third row and making it of the form z equals. So dividing both sides by 3 is the same thing as taking 1/3 of both sides of equation 3. And of course, store that result in row 3. Okay, so row 1 stays the same. Row 2 stays the same. Row 3 becomes, well, let's see, 1/3 of 0. Oh, this is where I'm saying it. The first two columns are not going to change anymore. It's going to be 0, 0, 1, and 1/3 of 15 is 5. So now we have exactly the statement z equals 5. We also have the statement y equals 3, And we also have the statement x plus z equals 7. Well, at this point, again, you may want to use substitution and say x plus 5 equals 7, so x equals 2. But when we're doing row operations, again, the computer that's going to be doing this for us soon is not going to know, is not going to be able to do this back substitution. So we're going to just do a row operation. Now we want to use this 1 here to help us cancel out this 1 up here. So if I simply take -1 of row 3 and add it to row 1, that will cancel out that 1. We're going to store that result in row 1. At the same time, because we're going to be taking multiples of these two zeros here and here and adding it to row 1, we're not going to change the first 2 columns at all. And that's the beauty behind this process and the order in which we're doing things. So row 2 is actually officially done. Row 3 is actually officially done because it has the 0, 1, 0, 0, 0, 1. The first row, however, is now going to receive -1 copies of row 3 added to it. So this is still going to be 1, 0 here because -1 times 0 plus 1, -1 times 0 plus 0. -1 times 1 plus 1, though, is going to be 0. And -1 times 5 plus 7 is going to equal 2, which we get the same answer as if we had tried to do this whole substitution process. So we're done at this point. We see that x equals 2, y equals 3, z equals 5, and as an ordered triple, we could list this as x, comma y, comma z equals 2, comma 3, comma 5. In vector form, we could also list this as the vector 2, 3, 5. And we've solved this system. Now you may want to go back and check, make sure these values work out. I designed the problem, so I know it does. In any case, you can see that there are lots of different things that you can try, but if you follow this general strategy of getting this 1, 0, 0 structure in the first column, you don't really worry about columns 2 and 3 while you're doing this, other than you're adding multiples of those to other rows. And then you move inwards to get your 1 in the middle, and then use that to pivot off of and cancel out the values above and below it. And similarly, for the third column, you want that to be 0, 0, 1. And then you get your 1 here and create zeros above that 1 in the third column. So I hope this has been helpful in giving you a more intuitive sense of how this process works.